section 813 is titled, How Can I Write the Equation? And the subtitle is Stretch Factors for the Polynomial Functions. Okay, so we're going to focus on figuring out equations that represent all of the points on the graph. So up until now, we've been just focusing on like where it crosses here and here. So for question number 39, it says, the direction save, write reasonable equations for each of the following polynomial functions without using a graphing calculator. How can you check the accuracy of your equations? Were all of your equations accurate? If not, why do you think your equations were not accurate? So I'm going to do B with you, and then you're going to do A and C with your groups because they're a little bit easier. A looked like the harder one, so that one I picked. Okay? So I highlighted in yellow this where it crosses the x-axis right here at -3. So that's going to be my factor of x plus 3. It crosses right here at 0, so that's going to be my x. And it flattens out, right? So it's not just x squared. Square is when it bounces off, and then cube is where it flattens out, okay? So that's going to be x to the 3rd power at 0 right there. And then the last intersection over here on the x-axis is at +2, so that's where my factor of x minus 2 comes from. The other thing I noticed is that the end behavior is going down towards -infinity. That means the whole polynomial is going to have that negative sign out front, right? You what? You hope it gets to -infinity, right? Okay. All right. Any questions so far? All right, so it does ask for an explanation. So I just wrote down my 3 x-axis intersections, one at -3, which gave me the factor of x plus 3 at 0 gave me x. It goes flat, so I made it x cubed. If it bounces off, that's going to be your square. And then my intersection of 2, that's where my factor of x minus 2 came from. Okay? I did count my directions. There were 1, 2, where it flattens out, counts as 3, up 4, and down 5. So it should be a 5th power. And so if you count this exponent right here, 3, 4, 5. So it is a 5th power, and it's negative because the end behavior goes down. Okay? So using similar techniques in your group of 4, you guys should be able to complete A and C, which are even easier than B. I picked the hardest one to do. Okay, I left the 2 easier ones for you to do in your group. All right, down at the bottom, question number 40 says, what is the difference between the graphs of the function x squared times x minus 3 times x plus 1 and the function 3x squared times x minus 3 times x plus 1? Okay, what you're going to notice is these are the first and the second are essentially the same. The only difference is that 3 right there, that coefficient of 3. What does that 3 do? It means that the second graph is going to have a vertical stretch. Okay? But pretty much the rest of the graph is essentially the same shape. That second one's just going to grow a lot faster. Okay? Any questions on 40? Anybody still writing? No? Okay, flip over to the top of page 11. Question number 41 says, Melvin wrote the equation y equals x plus 3 times x plus 1 times x minus 2 squared. The graph is shown at right. A. Explain how you can decide whether the equation represents the graph, and what can you do to the equation to make it a better fit for the graph, and what equation would fit it better. Okay? You can test a point. Okay? And on this one, it's going to need a stretch factor. And we're going to see it in part B, how to do that. But for now, this one is just going to need a stretch factor of 2. Okay? Where do we get that 2? How does the 2 come about? I mean, if you're using a graphing calculator, you could guess until you got it correct, right? But if you're not using a graphing calculator, you're going to do what we do in part B. Okay? Part B says, before you figured it out, you could have written the polynomial for this graph as P of x just is where I'm going to plug in my y in just a second, equals A, so that A is going to be your coefficient, your stretch, or your compression, whichever it ends up being, and this one ends up being a stretch, times x plus 3, times x plus 1, times x minus 2 squared. What if you did not have a graphing calculator, but you were told that the graph goes through the point 116? How can you use that information to determine the exact equation? Hint, think of solving for the A term like we did way back last semester for jumping the rabbit and the soccer ball, okay? When we had those parabolas, right, and we had to figure out the stretch factor, what did we do? We used a point, we plugged it in, and kind of worked backwards to figure out what that stretch factor was, okay? Once you have decided on a method with your team, try it. And how can you test the accuracy? Well, you could graph it and test another point and see if it worked, okay? So for part B, they tell us to use the point 116. They gave it to us right in the question. So we're going to plug in 1 for x, and we're going to plug in 16 for y. Even though they wrote it as in function notation, P of x, that's where the y goes, okay? So our y is 16, that gets plugged in there. For right now, we're just going to write our stretch or compression as an A, and then plug in 1 for x here, 1 for x here, and 1 for x here. Then we just simplify and solve for that A. So 1 plus 3 is 4, 1 plus 1 is 2, 1 minus 2 is negative 1, but negative 1 squared is positive 1. So we have 4 times 2 times 1, which is just 8. Then we divide both sides by 8, and that's where the stretch factor of 2 comes from, okay? So it didn't just magically appear here. Well, it did, but that's how you get it. You find a point on the graph where it's crossing at, on the grid correctly. I suppose you could even use a decimal point, but that would kind of be a little bit of a pain. But try and find one that's crossing at a corner, right? Plug it in for x and y, solve, and then you can get your stretch factor, and then it should work for all of the points on your graph, okay? Question number 42 is titled County Fair Coaster Ride. We saw one like this the other day. It says, now that you have more expertise with polynomial functions and their graphs, the Mathemericaland and Carnival Company has hired your team to write the exact equation to represent the roller coaster track. The numbers along the x-axis are in hundreds of feet. At 250 feet from the starting point, the track will be 20 feet below ground. This information corresponds to the point 2.5 and negative 0.2. Because they don't want us to have to use those larger numbers. Okay? So for part A, first question. What degree polynomial can be used to represent the portion of the roller coaster modeled by the graph at right. Does everybody see why it's 4? So if you start right here, you've got 1 direction, 2 direction, 3 direction, 4 direction. Okay? 4 directions, it's going to be 4th degree polynomial. Everybody good with that? Okay. What else is happening? Part B says, what are the roots? And is there a double root? Well, we've got crossing the x-axis right here at 0. And then at 2, because it bounces off of it, that's considered our double root. So it's twice. Okay? And then crossing again here at 3. Okay? So is there a double root? Yes. The 2 is the double root. Okay? Anybody still right? All right, turn over to the top of page 12, and we are going to figure out that stretch factor. Okay, so what is the equation for the polynomial that will generate this particular curve of the track? Okay, so we are going to use y, just because that's easier, but you could call it function of x, equals whatever the stretch or compression, we'll call that A, and then I just got these from where it intersected the x-axis. There was 1 at 0, there was 2 at positive 2, that was our double. You can write it as x minus 2 squared, but for me it was just easier to write it twice. And then there was an intersection at 3, so that's where my x minus 3 came from. Okay. Then I just used the point that they gave us back over here, right? I highlighted it in yellow. They gave us the point 2.5, comma, negative 0.2. So that gets plugged in here. So I plug in the negative 0.2 for y, and then I plugged in 2.5 for x. So that one just stays 2.5. We want to do 2.5 minus 2, which is 0.5. Same thing. And then 2.5 minus 3, that gets us a negative 0.5. Then I typed it in my punched it in my calculator because I didn't want to do all those decimals in my head. Okay?
Why?
I mean, you can. Go for it. I just wanted it done faster. So I multiplied 2.5 times 0.5 times 0.5 times negative 0.5, and I got negative 0.3125. And then I divided both sides by a negative. So if you divide a negative by a negative, you should get a positive. And so the A is 0.64. That means the equation for that roller coaster ends up being y equals the 0.4x times the x minus 2 happens twice, and then the x minus 3. Okay? Then this is their way of making you check it, make sure you did it right. They ask for part D. What is the lowest depth of the roller coaster's tunnel? Okay, so if you look back over at the picture, and here's the roller coaster, here is the lowest point, right? Where is that happening at? Halfway between 0 and 1, right? Halfway. So I just called it roughly 0.5. I mean, maybe it's at 0.49, but I just rounded and said it's very close to half. Okay? So I took that half and I plugged it in everywhere for x. So I plugged it in here, here, and here. And again, I just did it in my calculator, and I got a weird answer. I got negative 1.8, and I was like, wait, oh yeah, that's below ground, right? So this one goes in a tunnel underground, and they told us in the problem, which you might not remember, but it was in hundreds, okay? So it's roughly 180 feet below ground. And then I was like, oh, okay, that makes sense. Sometimes we need an answer like that.